Hey everybody, it's Dr. J, and today we're talking about mass percent. Let's talk about chemistry. So, mass percent. Mass percent is basically an element's percentage of the compound's total mass. That is it, right? It's a percentage game here. It's a percentage game. So we're trying to figure out that percentage of that element of the total of our mass. So in this case, we're going to use this equation over here. Mass percent of an element. How are we going to find it? Mass of an element, right? In this case, mass of whatever element we're looking at in that 1 mole of compound. Okay. So we're going to have that part on top. We got a part just like a normal fraction deal here, right? So we got a part. And then we have our, on the bottom, our denominator, the total compound's amount. So in this case, we're going to have the mass of that 1 mole of the compound. All right, so we got our part, right? And then we got our whole. And then once we have our number, we just have to multiply by 100 to get to our percentage, right? It's percentage game. So let's look at an example here. Find the mass percent of oxygen in butanol. Right now, butanol, what is that, Dr. J? That is C4H10O. Okay. So I got 4 carbons, 10 hydrogens, 1 oxygen here. But it's asking, what is the mass percent of oxygen in butanol? All right, so how are we going to do that? We're going to use this equation here, our mass percent equation. First, right, we got to figure out, well, what's the mass of element X in 1 mole of our compound? So butanol is our compound, right? But for the mass of element X, in this case, whatever it's asking, in this case, oxygen, we need to find that mass. So I need to understand, in order to find my mass of my oxygen, I'm going to first see how many oxygens I have. In this case, I have 1 oxygen times the molar mass of oxygen. In this case, that's going to be 1 times 16. Now, Dr. J, where did this 16 come from? The 16 came from the periodic table, right? We got to look at our periodic table. If you look at the periodic table, you're going to see a number, all right? You're going to see the atomic number, which the atomic number is a proton number. Then you're going to see a mass number, and that is what we're using here, 16. Now, you remember, right, I have grams per mole. Grams per mole is the molar mass. Remember, this is the molar mass. So this is telling me that for every 1 mole of oxygen, there's 16 grams. Okay, so this is what we see here. Now that I know, right, my oxygen here, what about my mole of compound? Well, if you want to find the molar mass of butanol, what do we have to do? We're going to add up all of our elements. That's it. That's all we're going to do. So how do I find the molar mass of butanol? Well, let's start out with carbon. So I see here in butanol there's 4 carbons. So I'm going to put 4, right, because I have 4 carbons as my subscript here. So 4 times the mass, right, the molar mass of my carbon. In this case, the molar mass of carbon is 12. Where are we getting that 12 from, Dr. J? We're getting it from the periodic table. You got it. So hydrogen, right? We have 10 hydrogens in butanol. This is where the 10 comes from. Bam. Now, what about our molar mass? If we look on our periodic table, once again, we have 1 gram per mole. All right, so we're literally getting these numbers from the periodic table. That's it. I can't say that enough. You want to get familiar with the periodic table. That is going to be your best tool in this class, really in chemistry. Okay, so you want to know the periodic table. You don't have to memorize it, but you should be able to interpret it. All right, so understand that periodic table. All right. Now, we got hydrogen squared away. Now, what about oxygen? I got 1 oxygen, 1, right? And then I have my mass. And what is my mass? 16, right? Because we just did it before. We found out that mass before. So 16 grams per mole, once again. Now let's add up all these together. And in this case, it's going to be 74. The real number is 74.1, so that's what I have here. But if you get 74, it's the same difference, okay? So the molar mass of butanol, once I add up all my carbons, all my hydrogens, and all my oxygens, is 74.1 grams per mole. That's the molar mass. Now, are we done? No, we're not done, because the question is asking for, well, what's the mass percent of oxygen in butanol, right? What's the mass percent of oxygen in butanol? Have I figured that out? Not at all. Let's figure it out. So now we can actually use our mass percent equation, which is telling me that the mass of an element X, in this case oxygen, will be on top. So I'm going to put my 16 right here. And then on bottom, right, is the mass of my compound, in this case 74.1, which I put on the bottom here. Okay. So how do I find the mass percent of oxygen? 16 divided by 74.1 times that 100, right? Because we're trying to get a percentage gain here, right? So that's going to be 21.6%. All right, and that is the mass percentage of oxygen. Shout out to 21 Savage, by the way, too. What if I wanted to calculate the mass percentage for carbon? Or what if I wanted to calculate the mass percentage for hydrogen? How are we going to do that, Dr. J? Well, let's do that one. So the mass percentage of hydrogen. Hydrogen, right, is literally taking this same concept here. We're going to do our parts. So in this case, the part is whatever element we're looking for. If I want to know the mass percent of hydrogen, I'm just going to have hydrogen on top. So we already determined it here, right? 10 times 1, that's going to be 10. Right? Because I have 10 hydrogens, and I understand that the atomic mass of hydrogen is just 1. 10 times 1. So I got my 10 on my top. And on the bottom, we already found the molar mass of butanol. So this is going to be super fast, right? 74.1 grams per mole. So 10 divided by 74 is going to give me my number. And then we just have to multiply by 100%. In this case, the mass percentage of hydrogen is 13.5%. Okay. Now what about the last one, carbon? Can we find the mass percent of carbon? You know my drill. Go ahead and pause me if you like. If not, let's get to it. So, mass percent of carbon. All right, so how exactly do we do this one? Right? Same thing. Okay. Mass percent of our element is always going to be the same. You're going to have that element on the top and then the total compound on the bottom, and you multiply by 100. Can't get any easier than that. So basically, if I want to figure out my mass percentage of carbon, I'm going to take my 4 carbons that I have here in my equation and my chemical formula, right? 4. And then I'm going to times by 12. Where am I getting the 12 again, Dr. J? Periodic table. Telling y'all, man, the periodic table is about to be your best friend. So you're going to have 4 times 12. That's going to be 48 grams. All right, over moles, right? It's the molar mass. And then from here, just divide by our molar mass of butanol, 74.1. Now, once we divide and multiply by 100%, we're going to see that the mass percentage of carbon, which is the most of this compound here, is 64.8%. So now we just determined our mass percentage of carbon, hydrogen, and oxygen. And here's always a way to double check your work. If you add up all your percentages, it should always equal 100%. So 21.6 plus 13.5 plus 64.8 equals 100%. If it doesn't equal 100%, something went terribly wrong, okay? So it should always equal 100% because this is, once again, mass percentage of our element. So basically, right, parts of these are going to equal my whole compound, just like a fraction. That's all it is.